Okay, so today we are going to study pOH. So pOH, such as we have pH equals to negative log to the base 10 of H plus ion concentration. In the same way we can write pOH equals to minus log to the base 10 of OH negative ion concentration. So we just replaced H plus ion with OH negative ion in the formula for pH to get pOH. So this formula is given in your data booklet. pOH equals to minus log to the base 10 of OH ion concentration. Okay, so we know that Kw is 10 to the power minus 14 mole square dm minus 6. This value holds good at 25 degrees Celsius. And we know that ionic product of water is Kw equals to H plus ion concentration multiplied by OH negative ion concentration. This we have studied previously. Now if we take the log of both the sides, taking LOG of both sides, we end up with log Kw equals to log H plus ion concentration plus log concentration OH negative ion. This is because if we take the log of A into B, log of AB is equals to log A plus log B. Therefore, when we take the log of H plus ion concentration multiplied by OH negative ion concentration, it will come out to be log concentration H plus plus log concentration OH negative. Now if we multiply by negative sign on both the sides, we get minus log Kw equals to minus log H plus ion concentration minus log OH negative ion concentration. Now we know that minus log H plus ion concentration is pH and minus log H plus ion concentration is pOH, and Kw value is 10 to the power minus 14. If we take the log of it, so we will get 14. So we got the formula pH plus pOH equals to 14. So if you know the pH of a solution, you can find the pOH by just subtracting it with 14, subtracting from 14. So this is another formula, pH plus pOH equals to 14. Okay, so now we will study the equilibrium constant of acid Ka and equilibrium constant of base Kb. Okay, suppose this Ha is my weak acid and it dissociates into H plus ion and A negative ion. So I can write the dissociation equilibrium constant of acid Ka equals to H plus ion concentration multiplied by A negative ion concentration over concentration Ha. Just as we wrote that pH equals to minus log to the base 10 of H plus ion concentration, in the same way we can write the formula for pKa equals to minus log to the base 10 of Ka. And in the similar way we can write pKb equals to minus log to the base 10 of Kb. So we have two formulas here. pKa equals to minus log to the base 10 of Ka, that is the equilibrium constant of acid, and pKb equals to minus log to the base 10 of Kb. Okay. So if Ka increase, if the equilibrium constant of acid increase, the value increase means we have more of H plus ion concentration and more of A negative ion concentration, and then our Ka will increase. In that case pKa will decrease. So if Ka increase, pKa will decrease. So if Ka increase means there is more dissociation of the weak acid. So we have a strong acid if Ka is more. Strong acid. If Ka is less, if Ka is low, pKa will be high and we will have a weak acid. In the same way, if Kb is more, pKb will be less, pKb will be low, and then we will have a strong base, because I can write down that weak base, suppose ammonium hydroxide dissociate partially to ammonium ion and OH negative ion. I can write the Kb, equilibrium constant of base, as ammonium ion concentration multiplied by OH negative ion concentration over concentration of ammonium hydroxide. So if we have a strong base, we will have more concentration of ammonium ion and we will have more concentration of OH negative ion, and then pKb will be less and we will have a strong base. Now if Kb is low, we will have pKb value will be high, and in that case we will have a weak base. So this is the relationship between Ka and pKa, Kb and pKb. So we have an inverse relationship between Ka and pKa, and similarly inverse relationship between Kb and pKb. Okay, so now we will study the relationship between conjugate acid base pair. So conjugate acid base pair relationship. So we have already studied what are acid base conjugate acid base pairs, right? So if there is a strong acid, it will give us weak conjugate base, and if it is a weak acid, it will give us a strong conjugate base. So let us assume that HA is our weak acid. It dissociates partially to give H plus ion and E negative. So this is our weak acid, and E negative will be our strong conjugate base. Okay, so now we can write the equilibrium constant for this acid. Ka equals to H plus ion concentration multiplied by A negative ion concentration over concentration of HA. Now A negative, this base can react with water. This base can react in water to give us HA and OH negative. We can write the equilibrium constant for this base as Kb equals to concentration HA multiplied by concentration of OH negative ion divided by concentration of A negative. Concentration of water is considered as 1 because it is a pure liquid. Now if we multiply these two equations, equation number 1 and equation number 2. If we multiply this equation, so what we will get? We will get Ka multiplied by Kb equals to concentration H plus ion into concentration A negative over Ha multiplied by concentration Ha into concentration of OH negative ion over concentration of A negative. So this cancels out, and this cancels out, so we are left with Ka into Kb equals to concentration H plus ion multiplied by concentration OH negative. And we know that this value is what? This value is Kw. So we got a relationship between Ka and Kb. Ka into Kb equals to Kw. Kw is the ionic product of water. Okay, so we saw that Kw equals to Ka into Kb. If we take the log of both the sides, we will get log Kw equals to log Ka into Kb, and we know that log A into B is log Ka plus log Kb, and this is equal to log of ionic product of water. We know that Kw is 10 to the power minus 14, right? Mole square dm minus 6. So if we multiply this equation by minus on both the sides, we will get minus log Kw equals to minus log Ka minus log Kb. Okay, if we take the log of 10 to the power minus 14 multiply it by minus sign, we will get 14. And what is this? Minus log Ka, that is pKa. And what is minus log B? That is pKb. So we got a relationship pKa plus pKb equals to 14. So if you know the pKa, we can find the pKb, and if you know pKb, we can find pKa. Okay, so now we are going to study the pH of salt solutions. pH of salt solutions. So the pH of salt solution will depend upon the relative strength of their acid and base. Let us take an example. The pH of the salt of strong acid and strong base. Salt of strong acid and strong base. So example of the salt of strong acid and strong base is sodium chloride. So if we dissolve sodium chloride in water, it will give us sodium ion and chloride ion. Sodium ion do not react with water. There is no reaction. In the same way, chloride ion also do not react with water. There is no reaction. So the pH of this solution will remain neutral, pH equals to 7. So if we dissolve a salt of strong acid and strong base in water, the pH of that solution will be 7. Okay. For example, we dissolve our table salt, which is sodium chloride, in water. The pH remains the same. pH remains neutral. Now another case, if we dissolve salt of strong acid and weak base, salt of strong acid and weak base, salt of strong acid and weak base. For example, salt of strong acid and weak base is ammonium chloride. So if we dissolve ammonium chloride in water, we will get ammonium ion and chloride ion. Okay. Now ammonium ion can react with water in the equilibrium to give us ammonium hydroxide and H plus ion. Now we know that ammonium hydroxide is a weak base, and therefore its conjugate will be strong acid. And we know that in an equilibrium, the equilibrium lies towards the weaker conjugate, so equilibrium will be towards right hand side, towards the product, and therefore we will have more concentration of H plus ion in the solution, which will make the solution acidic. So pH of the solution is going to be less than 7. And as far as the chloride is concerned, chloride will not react with water, there is no reaction. So our pH is going to be less than 7 because of the presence of this H plus ion. So when we dissolve a salt of strong acid and weak base in water, we will get a solution with pH less than 7, means we will get a solution which is acidic. Now let us take another case. If we dissolve the salt of strong base and weak acid, strong base and weak acid in water, if we dissolve the salt of strong base and weak acid in water, what will happen? So the example of the salt of strong base and weak acid will be CH3CONA, sodium acetate. So this is sodium acetate. If we dissolve this in water, we will get acetate ion and sodium ion Now sodium ion do not react with water, there is no reaction. However, cetate ion can react with water in an equilibrium reaction to give us acetic acid and OH negative ion. And we know that acetic acid is a weak acid, so its conjugate will be a strong base. And as we know that the equilibrium lies towards a weaker conjugate, so equilibrium will be towards the right hand side, and therefore we will have more concentration of the OH negative ion, and as a result our solution will be basic. pH will be greater than 7, basic solution. So if we dissolve a salt of strong base and weak acid in water, we will get a basic solution. Now so now take an example of the fourth category, salt of weak acid and weak base. Salt of weak acid and weak base, for example ammonium acetate. Okay, so when we dissolve ammonium acetate in water, we will get ammonium ion and acetate ion, CH3CO negative. Acetate ion can react with water in an equilibrium reaction to give acetic acid and OH negative ion. And our ammonium ion can also react with water in an equilibrium reaction to give us ammonium hydroxide and H plus ion. Now we know that acetic acid is a weak acid. Its conjugate will be a strong base, weak acid, and conjugate is a strong base. So the equilibrium will be towards the right hand side, so we will have more OH negative ion concentration. In the same way, ammonium hydroxide is a weak base. Its conjugate will be a strong acid, and as we know that the equilibrium lies towards a weaker conjugate, so equilibrium will be towards the right hand side and we will have more of the H plus ion concentration. So H plus ion will react with OH negative ion to give us water neutral. So therefore the pH of this solution will be nearly equals to 7, almost neutral. So if we dissolve a salt of weak acid and weak base in water, we will get a neutral solution.